All right, let's dive right in. Today, we're going to pull back the curtain on the massive, and let's be honest, kind of complex world of AI infrastructure. We're going to break down everything from the tiny silicon chips to the huge cloud services that are really powering all the AI tools changing our world. Let's get to it. So, let's just ask the big question right up front. What does it really take to power this AI revolution we're all living through? Because it's not just about brilliant code or some clever algorithm. It's built on a massive physical and software foundation that makes it all possible, and that's exactly what we're going to unpack.
It all starts with this physical foundation. And this isn't some far-off future stuff. It's already transforming pretty much every industry you can think of.
And the impact is just staggering when you stop and look at it. In healthcare, AI is modeling diseases to help us find new drugs. Over in finance, it's spotting fraud with an accuracy that's just incredible. Car companies are using it to design and simulate self-driving cars. And of course, the big one, generative AI, is completely flipping the script on how we create content. This is the why. This is the reason all the infrastructure we're about to talk about matters so much.
So, what's at the very heart of all this? What's the engine driving modern AI? Well, it's the GPU, the Graphics Processing Unit. Let's take a look at why this one piece of hardware is so unbelievably critical. The best way to get this is to think of a restaurant kitchen. A CPU, your computer's main processor, is like a master chef. He's a genius, right? He can handle any complex task you throw at him, but he does it one step at a time. A GPU, on the other hand, well, that's an entire army of line cooks, all chopping carrots at the exact same time. It's designed to do thousands of simple, repetitive tasks all at once, in parallel. And it just so happens that's exactly what modern AI needs, that massive parallel power.
And this whole process has a name. It's called GPU acceleration. It's really a partnership. The CPU handles all the general purpose stuff, but when it hits one of those giant, repetitive calculations, it offloads it to the GPU. This teamwork is what makes it even possible to train and run today's huge AI models in a reasonable amount of time. Without it, we'd be waiting for years.
So, to really get why the infrastructure is built the way it is, you have to understand the workflow. It basically boils down to these 4 steps. First, you've got to prepare these massive data sets. Then comes the really heavy lifting. You train the model on that data. After that, you optimize it, and finally, you deploy it for what's called inference. That's when it's out in the world making predictions on new data. And every single one of these steps places unique demands on the hardware.
Now, as you can probably guess, that entire workflow doesn't happen on a single computer, not even close. It all goes down inside a specialized AI data center, and these places are really built on 3 fundamental pillars.
First up, pillar number 1, compute. This is the raw horsepower. We're talking about servers just jam-packed with powerful GPUs, all there to do the heavy lifting of training and inference. But all those GPUs are pretty useless if they can't talk to each other, right? That's where pillar 2 comes in, networking. Think of this as the data center's nervous system. You need blazing fast, super low latency connections so that thousands of these GPUs can work together like a single brain without any bottlenecks.
And finally, you have to feed the beast. That's pillar 3. Storage. AI models are hungry. They train on absolutely gigantic datasets. So you need high-speed storage systems that are constantly shoveling data to the GPUs, making sure they are never sitting around idle.
Okay, but here's the thing. Having all that incredible hardware, the compute, the networking, the storage, that's only half the battle. That hardware is basically just a very expensive pile of metal without a sophisticated software stack to unlock its potential and actually bring it to life. And that software stack has a bunch of key layers. Way down at the bottom, you have drivers that let the software talk to the hardware. Right on top of that, you have something like CUDA, which is the critical platform that lets developers actually tap into that parallel processing power of the GPU. As you go up, you have things like containers, which package up apps so they can run anywhere, and deep learning frameworks that give developers the building blocks they need. This entire stack, working together, is what turns raw silicon into a platform where you can actually get work done. Okay, so you've built your hardware pillars, you've layered on all the software. Now what? How do you actually manage this incredibly complex AI factory efficiently? This is where management and orchestration become absolutely essential. It's everything. The discipline for managing all this is called MLOps, or Machine Learning Operations.
The entire goal here is to make the whole AI development process reliable and repeatable, kind of like what DevOps did for regular software. MLOps tools are what makes sure resources are used efficiently and that a project can go from one person's little experiment all the way to a full-scale production deployment without falling apart.
And within MLOps, it's really important to know the difference between orchestration and job scheduling. Think of an orchestrator like Kubernetes. It's perfect for inference. It manages live applications, scaling them up or down depending on how many people are using them. A scheduler, like Slurm, is different. It's a master of the training process. It takes a huge, long-running training job and figures out the most efficient way to assign it to a cluster of hardware. The bottom line? You absolutely need both to run an efficient AI factory.
So there you have it. We went from the silicon inside a single GPU to the 3 giant pillars of the data center, up through the entire software stack, and all the way to the MLOps that manage the whole show. That is the anatomy of modern AI infrastructure. The factory is built. The tools are all ready to go. The only question left is, what problem will you solve?